Welcome back to our latest explainer. Today we are officially crossing a massive, massive threshold in the evolution of artificial intelligence. We're unpacking this overarching theme of production agentic engineering. If our previous deep dives were all about, laying down that mathematical and conceptual foundation, well, today is about actually building the skyscraper. We're moving completely out of those theoretical, isolated models and jumping right into the nuts and bolts of production-ready, highly capable AI. We're talking about systems that can literally execute complex workflows completely autonomously. It's going to be a fun one. Okay, let's dive right into this. Here's our exact roadmap for unpacking this pivotal stage. We'll start with a welcome to day 15. Then we'll look at the ultimate project goal. Next, we'll break down the 3 learning pillars. And finally, we'll wrap up with building the AI team. Section 1. Welcome to Day 15, Multi-Agent Systems. So, Day 15. This is definitely not just another milestone. It represents a major, major leap in complexity for production agentic engineering. Up until this point, we've kind of been operating in a very linear sequential paradigm, right? You give an instruction, the machine processes it, and boom, it spits out an answer. But multi-agent systems? This introduces an entirely new dimension. We aren't just thinking about a single isolated intelligence that's bottlenecked by its own context window anymore. No way. We are stepping into a totally dynamic ecosystem. This means moving from simple linear processing straight into the realm of parallel, autonomous interactions. We're talking about multiple models running concurrently, triggering one another, and actually evaluating each other's outputs in real time. This orchestration of parallel intelligence, man, this is where the magic absolutely starts to happen in modern AI development. Section 2. The ultimate project goal. What we are building. Think about our baseline up to now, the single AI agent. It's basically one prompt, one agent, one output. It's safe, it's predictable, and honestly, it's highly constrained. But now compare that to a team of AI agents. Moving from just one single agent to a whole team is an absolutely immense engineering challenge. We aren't just scaling up compute power here, we're dealing with really complex architectural hurdles. The second you introduce multiple agents, you suddenly have to manage state across distributed nodes, handle compounding error rates, and engineer these robust fallback mechanisms, just in case one agent decides to hallucinate. So we really aren't just building a simple software tool anymore. We are literally engineering an autonomous digital workforce that actually needs to effectively govern itself. Let me actually read the official project assignment right from our source outline. It just says, Project Team of AI Agents. It's beautifully simple, right? But also incredibly daunting. And why is it so daunting? Well, mostly because of the sheer unpredictability of AI to AI interactions. Think about it. When one large language model feeds its output directly into the input of another model with zero human intervention, even minor hallucinations can cascade into catastrophic system failures. Mitigating that risk requires incredibly precise engineering, so this final deliverable is really momentous. Every single framework, every protocol, and every constraint we establish from this exact moment forward is laser-focused on successfully delivering this project without the whole thing just spinning out of control. Section 3, the 3 learning pillars. How we get there. So the crucial question here is, how do we actually build that team? Let's shift gears from that ultimate project goal over to the specific engineering objectives we need to make it a reality. The architecture outlines 3 exact building blocks. We have collaboration, roles, and communication. And the truth is, you simply cannot build a stable, production-ready multi-agent system without mastering every single one of these pillars at a highly technical level. So let's break them down individually and look at the underlying mechanics, shall we? First up is collaboration. This is the very first learning objective required for building multi-agent systems. And in an agentic framework, collaboration isn't just about, friendly teamwork. It is a hard, complex engineering problem. You're dealing with multiple models that all have their own distinct internal states. So to make them actually collaborate, you have to engineer the environment in a way that gives them a shared, unified objective function. Essentially, this means programming them so they don't end up competing for resources or accidentally overwriting each other's progress. You have to establish shared context windows so that Agent A knows exactly what Agent B just accomplished. You're aligning their reward parameters so a successful output from one triggers the correct next action in the other. It's really about mathematically ensuring that their combined outputs converge on that target goal rather than just diverging into total chaos. Next, we move on to roles. This is the second learning objective required for building multi-agent systems. Look, you can't just spin up 5 identical agents doing the exact same thing. That's just compute redundancy. It's not a functional system. A truly cohesive architecture requires distinct, technically defined functions for everyone. For example, you might engineer one agent to be the actor or the generator. You'd prompt it with a really high temperature setting to encourage creative, divergent thinking. But then you'd pair it with another agent acting as the critic, and you'd configure that one with a temperature of absolute zero, along with rigid, rule-based constraints designed entirely to verify facts and tear down the actor's mistakes. Understanding how to define these system prompts, assign these exact constraints, and perfectly balance those opposing configurations, well, that's what makes a multi-agent system so highly efficient and remarkably accurate. Finally, we have communication. This is our third learning objective required for building multi-agent systems, and it's basically the integration layer. So you have agents mathematically aligned to collaborate, right? And you have agents set up with highly specific system configurations. But how do they actually pass data, feedback, and contacts back and forth between each other? Unpacking communication really means engineering specific protocols. We're talking about formatting outputs into rigid JSON payloads so that the receiving agent can actually parse the data reliably. It involves building these autonomous feedback loops, where an agent can actually request clarification from another node if a prompt seems ambiguous. Plus, you have to maintain conversational memory states across the whole network so that crucial context isn't lost over a long sequence of tasks. Because without this robust communication infrastructure, your team of agents is really just a group of isolated models throwing text out into the void. Section 4. Building the AI team, bringing it all together. So, let's look at how this all builds toward our final outcome. Step 1. You acquire the 3 core skills. You architect how the agents collaborate, you assign them distinct operational constraints, and you establish their JSON-based communication protocols. Then step 2. You actually deploy the final multi-agent project. But honestly, this deployment phase is where the friction really hits. Bringing it all together requires a highly sophisticated orchestration layer. It's essentially a master controller program that routes the tasks, monitors the API calls for timeouts, and manages the overall compute budget. It's a very structured path from foundational theory straight to practical production-level engineering. You master those technical pillars, you build out the orchestration layer, and finally, you deploy the team. To wrap up, I really want to leave you with this thought, which comes directly from the core themes of our explainer today. We know how to set up the objective functions for collaboration, we know how to configure the distinct roles, and we know exactly how to wire those communication protocols. But what actually happens when a team of AI agents starts communicating, iterating, and collaborating entirely on their own? Once we deploy this framework, the potential scales exponentially far beyond our initial prompts. This is honestly just the very beginning of understanding the true power of autonomous agentic engineering. Anyway, thanks so much for joining me on this explainer, and I will absolutely see you in the next one as we continue to build this out.